Let's take this interesting question on complex number, and it says that predict the nature of triangle having the vertices z1, z2 and minus omega z1 minus omega square z2, where as you know, omega is an imaginary cube root of unity. So let's plan it in this way. Suppose in the argument plane, suppose this is the imaginary axis, this is the real axis. Let's plan about two complex numbers z1 and z2. So suppose this is one complex number z1, this is another complex position vector z2, and so let us level it. Suppose this is z1, this is z2, okay. And what about the third one? So this is a pretty interesting one and tricky one. This is minus omega z1 minus omega square z2. So we can plan it in this way, that is we can write down this minus omega part as 1 plus omega square, okay, because we know 1 plus omega square is 0. So the third vertex will come out to be z1 minus omega square into z2 minus z1, okay. So in this way we can write down the third vertex of the triangle, that is z1 minus omega square into z2 minus z1. Now I think the analysis part is going to be much easier, because you see that what is happening is that this z2 minus z1, this particular vector we can easily plot, because this particular vector is going to be the line joining z2 and z1. So this is the direction of z1, this is the direction of z2, so this must be the direction of z2 minus z1. So this is z2 minus z1. Now what is happening? Minus omega square is getting multiplied with z2 minus z1. Now minus omega square is nothing but, you know, the Euler form of minus omega square is e to the power, right? Like minus 1 can be written as e to the power I pi, and omega square can be written as e to the power minus I 2 pi by 3, okay. Minus 1 is e to the power I pi and omega square is e to the power minus I 2 pi by 3, so collectively they are going to be e to the power I pi by 3, okay. So minus omega square can be claimed to be e to the power I pi by 3. Now what we are doing is that this z2 minus z1, this particular displacement vector, is getting multiplied with a number that is minus omega square, that is e to the power I pi by 3. Now e to the power I pi by 3, as you know, is an unit vector because the magnitude is unity, but the argument is pi by 3. So basically what will happen is that this particular vector z2 minus z1 will be rotated in the anti-clockwise direction by an angle pi by 3. Okay, so we can rotate the vector z2 minus z1 in the anti-clockwise direction by an angle pi by 3, keeping the magnitude intact. So this is going to be the vector. So this will be the vector minus omega square into z2 minus z1, okay, because we have just rotated the vector z2 minus z1 in the anti-clockwise direction by an angle pi by 3, which is 60 degrees. So this much angle is coming out to be pi by 3, okay. Now you see that we are going to add the vectors z1 and minus omega square into z2 minus z1. So now we need to add the vectors z1 and minus omega square into z2 minus z1. So to add these two vectors, we can apply the triangle law of vector addition. So according to the triangle law of vector addition, we can easily see that the resultant is going to be this particular vector, okay. So this is going to be the resultant. So we can easily see that this is going to be the third vertex of the triangle, this is the first vertex of the triangle, and this is the second vertex of the triangle, okay. So let's complete the triangle now. We have got the triangle. So this is going to be the triangle that we are talking about, having the vertices z1, okay. So this is z1, then z2, this is z2, and minus omega z1 minus omega square z2, that is basically this particular point, that is minus omega z1 minus omega square z2. So these are the three vertices of the triangle, and now we can see that this triangle is clearly an equilateral triangle, because you see that this particular length and this particular length are equal, because we have rotated this vector keeping its magnitude intact. So this length and this length are equal, and the included angle is 60 degree. So we can claim that the answer is going to be an equilateral triangle. This is going to be the nature of the triangle.